So, and let's have a quick look on the agenda. We're already at point 1, welcome in intro. My name is Alexander Loth, and I'm here together with Daniel Kompe. We are your hosts for this meetup today. Then we will hand over to Bernhard Düchting, who will show us some awesome use cases for Azure SQL DB. Then our principal program manager, Mark Gromer, will show us Azure Data Factory, followed by Sascha Dittmann, who will show us Azure Synapse Analytics. And last but not least, Shimon Mosesson will give us some ideas about how to visualize your data in Azure with Power BI. So the good thing for today is you don't need to take any notes. We'll provide the session material on our Data and AI GitHub repository afterwards. So this link is all you need. Before the bootcamp kicks off, Daniel, would you like to tell us which meetups comes next?
Yes, please mark your calendar for the next meetup around data and AI in healthcare on the 16th of July, starting 4 p.m. in the afternoon. We already have a packed again agenda with some cool use cases from healthcare hospitals in special Sana Kliniken will tell us about BI as a service, about how to handle data for their customers and for their patients. And we do have prepared some COVID stuff and around how I will handle all the data that came with COVID and digitalization in Germany. So mark your calendar for the July of 16th. And feel free to bring your own ideas, your recommendations, your proposals to us, although we could arrange a new and another next meetup with your interest, with your topics, with your things you are considering about data and AI. And feel free to visit us at AKAMS Speak AI and feel free to get in contact with us. And without further ado, I will hand over to Bernhard, who's telling about SQL. Bernhard, your stage.
Yeah, thank you, Daniel. Yeah, welcome to the Azure Meetup. Today, my name is Bernhard Düchting. I'll also promptly share my screen. Okay, almost done. No, that will do it. Yes, I'm a cloud solution architect for data and AI at Microsoft in Germany. I have a pleasure really to giving you an overview and also a demo of our SQL database in Azure PaaS as a service and what we have there. Also, what other components we have on Azure. And some of you may have followed really how we were announcing SQL database on Azure about 3 years ago. It has been developing into what we call today the intelligent cloud database service, because it has just more than just providing a PaaS service, really, where you have the same view on your data that you would have on premises with your favorite tooling like SQL Server Management Studio, but it's more. It's actually intelligent because we're using machine learning and other cognitive services really to enrich your experience, including security, where we have on Azure our automatic threat protection defender. So as you can see, the evolution, starting with your SQL Server on premises. I've been putting in an older version on purpose because I'm going to show you a migration really with a demo to really deploy a SQL Server onto Azure SQL Database. And as you go up the journey, the next thing you're going to see is really, okay, let's deploy SQL Server as is, even let's say example here, 2017 on Azure VM. That makes it infrastructure as a service. I'm sure you are familiar with that, because that would save you like providing the platform. It's already visualized. We take care of everything else, the hardware and also the management in our Azure data center. The final step would be going to the right side, deploying to Azure SQL Database as a service, where now we are taking care of things like, of course, operating system. When you are going on infrastructure as a service, you had a choice, either Linux or Windows. Here we take care of that. You just don't care. It is SQL Server as you know it. You are in control of your data, your applications, and we have added, as I mentioned before, intelligent machine learning and cognitive services to make really the best use of your performance, because we are detecting things that could be improved to get a better performance, and as I mentioned, also to secure your data with Azure Threat Protection. And as we get even closer, you will find that we have more than one deployment option, which is the Azure SQL Database. It starts with the singleton database. That's how we're starting. It's database scoped deployment, as you would know it, with predictable workload performance on a given performance layer. And we have a metric for that, which I will explain. It's a database transaction unit, DTU. So it's a new metric really to define where you want to go and how much performance you need. And of course, we have a number of tiers, starting with basic and then other tiers, which I will show you to you in the next slide. However, that's not all. The next candidate that was added sometime later is the elastic pool, which allows you to share a number of databases and put them inside a given elastic pool, also of a given elastic DTU, eDTU, and that will also be managed as part of the elastic pool. It can go up and down, so it's really scaling up and down, hence elastic, and still a shared resource model to give you greater efficiency for multi-tenant applications. So when you have more than just one database and you have requirements for multi-tenant applications also on premises, and you want to deploy that on Azure as well, that would be a candidate for Azure SQL Database with an elastic pool. Also very well for ISV partners who have applications like this with multi-tenant architecture. Going forward with an elastic pool would give them, and we have seen that, significant cost savings, meaning cost savings on Azure means Azure consumption savings. And the last candidate here on the right side is Azure SQL Database Managed Instance. Azure SQL Managed Instance, which is now instance scoped deployment. So if you think about
Bernhard,
yeah,
it's Daniel just checking. We have a chat here that your sharing might be stopped.
Oh, okay.
I don't know. Now it's back again.
He's still sharing.
Okay, good. Thank you. No. Oh, okay. Go ahead.
Since I'm flying in the blind, thank you, Daniel.
Yeah, just
making me aware. And also, if there are questions or anything else I will pause if there are questions, of course. Yeah. So Azure SQL Managed Instance is, in contrast with the other options, which are database scoped, it's instance scoped. So if you have, again, look at a situation where you're hosting a number of SQL servers on premises, yeah, typical hoster really operating an application, yeah, with remote access or in your data center. Then you really want to move this up, to lift this really to Azure with minimum change, but still with the same tools that you're that you're using to work with SQL Server. And that will be the managed instance, where everything is put as an instance inside a managed instance environment, and the access from outside. Also, when you go to Azure with the application using a web app service, is going to a public endpoint to the managed instance. Yeah, there's only one public endpoint, which of course you can protect. And then, as you are inside the managed instance, you will find the instances that you had been deploying before. So it's best for modernizing applications. If you really want to deploy a complete application, which typically is running on a number of SQL servers, just almost like lift and shift, I would recommend using managed instance. Okay, as I mentioned before, we have different service tiers, which I will show to you, starting with basic, standard, and then premium. And then, as you can see, there are further additions which we had announced at this Ready conference this year, so in springtime, summer this year, which is Hyperscale, which allows a single Azure SQL database to scale up without impacting operations. So you can say, okay, I need, let's say it's running on 10 terabyte, and you want to increase it because you have a significant load coming in. For example, by working with streaming data, you want to go up to 10 times. Yeah, like 100 terabyte. That will happen in a number of seconds and minutes at most, without impacting the operations and without impacting if you're doing any other queries and operations on the Azure SQL database. That is called Hyperscale. And the last edition also came out just, I think, a month ago, is serverless, because the future is really going serverless, meaning you have a service, which is the SQL database on Azure, and all you need to define is really how much you need, how much virtual CPUs you would need. That's min and max, and minus is a minimum. And in between there, really, the system is giving you what you need. And if it's pausing because, well, there's no load on your serverless Azure SQL database, it'll stop really. And so also there will be no Azure consumption. So really what you expect from serverless. And we have other services in Azure which are serverless, like Azure Logic Apps, for example, to name just one here, and Azure Functions. And that's the future, going serverless. But we're still talking database, it's still SQL database. And the way it feels, I will show you, because it's really very familiar working with your familiar tools, including SQL Server Management Studio and Visual Studio as well for development, as you know it. So regarding metrics, when you look at Azure SQL Database and all the options, we have a new metric, which I explain here, is the DTU model, Database Transaction Unit. It's a bundled method of compute, storage, and I/O. So we have designed this really based on our own metrics and measurements. So it's because, as you can see, as the DTO goes up, you have more compute and also more storage at the same time. And you can select that, and even you can change that as you go. So if I show you, and I will show you an Azure SQL database in the Azure Resource Management portal, you can define this like a slider, how much DTU you need. So it's very, very easy. Of course, within a given tier. Yeah? I mean, if you are within beta tier, you have limits. But let's say you go to standard, you have a bigger limit and range, and you can really adjust as you wish. To the right side, we have also the vCore model, where still the compute and storage metric are separate, and here you can choose the best tier really compared to what you need in terms of compute and the storage you need. So that's really up to the developer to make those choices. And you will see also in the demo, you're getting recommendations from Azure recommendations, what would be best for you when you go in and deploy your Azure SQL database. No. It's also interesting as you start the journey, just to mention this detail, you have majority maybe on premises in your data center, and you start the journey, then we have something that we call Azure Hybrid Benefit, which is also describing when you're going hybrid, you have some SQL Server on-prem and some SQL Server on Azure. And here with the vCore model, that will give you additional benefits to move SQL Server that you have licensed based on your on-premises licensing. You can start moving to Azure. That's called Azure Hybrid Benefit. My colleagues here, the Azure specialists, can give you details about that. Okay, let's take it to the next step, which is looking at elastic pools. It is really about scaling multiple databases across a shared resource, which is the elastic pool. Here we go. You also have the DTU as a metric to deciding how much database burst level you need. So 200, 400, 800, and 1200 as an example, and it can go up to 3,000 databases. And when you go to premium tier, it's actually going up to 4,000. And because it's also connected to the elastic pool, we call this an elastic DTU. When you are dealing with the singleton Azure SQL database, it's called just DTU. That's the explanation. You can create and configure your pools using the Azure portal, using PowerShell, and also including the use of REST API. So it's also programmatic. You can make changes also programmatically through REST API. And obviously, using PowerShell scripts, you will find one PowerShell script on GitHub after this meeting here, where you can it'll create a new database for a given Azure SQL database on Azure within very short time, much quicker than just doing it on the portal. Just for you, just to give it a try. And it's all speaking, of course, T-SQL. That's always what we like to do, having one interface, which is T-SQL. Also, when you go ahead, also talking about SQL Server 2019, when you use Polybase, for example, to include or integrate with other databases like Oracle, for example, but also integrating with Spark cluster and Hadoop. It's all speaking T-SQL. And I'll also show you the geo-replication. That's a way to increase the service level availability of 99.99 yet again, because you can spread the Azure SQL database in the same or different region. I will show that to you. I have one example where I've done this with one Azure SQL database in West Europe and North Europe. And all you do in Azure is, of course, include in the Azure monitoring capabilities, which you will see it's connected, so you can just look, okay, is it busy now, what's going on? And you can add other means of tracking access through inspection. And that applies both to Elastic pools and also to Azure SQL databases. You will find in the slide deck later that I have a link here to Microsoft videos. These are all links to Microsoft videos with a bit more detail as part of, you have maybe heard about this, some are being done as a part of the Channel 9. So they're all done from Microsoft product managers who will explain a little bit more in detail. Yeah, this is a graphical illustration. I think without further ado or further comments, depending on the tier here is SU. That's the smallest one. It's also the free tier. You can start there. and you see it's can only do so much. As you go up, more people users, but also more databases can go here on the elastic pool. Very simple, and can go up and down. It's elastic. It goes up and down with the requirements. Yeah, that's the explanation of our service tiers. You're starting with basic tier, up to 5 elastic DTUs per database, then standard, as was seen before, up to 3,000 elastic DTUs, and premium. You have done this also because of requests from the industry, up to 4,000 elastic DTUs, and also up to 4 terabyte storage, because we're seeing this request, and that's a premium tier. And to find out what that means in terms of Azure consumption and also cost, you all know our Azure price calculator, I would assume. If not, you can just make a comment in the chat window. I can show you an example in the Azure price calculator, because that gives you an indication how much you would need given your requirements. Okay. Good on. You tell me when there is a question, otherwise I will just slowly go ahead.
There was one question about switching between serverless tiers and the standard ones.
Yeah, thank you. You can run both tiers, but not switching between tiers. So you either go to serverless, and then if you want to access the data in Azure SQL Database, not serverless, of course that's possible, but the older ones will still be deployed in the DTUs. So you would gradually switch over if you want to use serverless. I think it's a decision to make really when you start. It's best really, but if you want to do it later, it's possible. Yeah, the big question: why did we come up with Azure SQL Managed Instance? Because we have seen that customers running multiple or multi-tenant applications in their data center, number of SQL servers, they would like to have a similar layout really as they deploy to Azure. So together with the app, yeah, that was the idea behind it. And this to do with minimal effort and also with the cost in mind. That's why we have the managed instance, because it's really an environment. It's also in the Azure monitor, in the portal rather. Sorry, when you look at it in the portal, it's really one managed instance which contains a number of SQL instances. Yeah, so it's almost like an entity, and you can access with public endpoint and also with VNet peering. Here it is. So, and you have dedicated resources really, and they are isolated from the rest of your Azure realm. So look at that. You have your on-premises on the right side, either with VPN side to side, or as need be using Express Route Gateway, whatever makes sense. You will reach the endpoint for the managed instance. Inside, it's almost like a virtual data cluster. So inside you have the SQL instances. And there can be more than 3. It's just here an example. And for the rest, you have VNet peering, as we call it, when you have the application, of course, like before on premises, working against a multi-tenant environment where you want to access these instances as need be, because it's still the same application, but it's also now deployed. Here, the access is done through the web app service. And the question what to do with the application, it can be either also ported and migrated to Azure, or also accessed on-prem in your data center. A quick outlook to what's called Azure SQL Database Hyperscale that was announced at the last ready. And it came really from thinking about the needs that we see when dealing with very large databases, which of course we also were supporting using SQL Server before, also on premises, but sometimes it would take the operations really much longer to complete. Performance could be degraded. There may be outages and downtime, especially with operation on premises. And you want to have the ability of scaling compute up and down. That wasn't really possible with on-prem. Hence, the idea of having hyperscale. It's a new service. And here you can really start as low as you think it's meaningful, and then also scale up. And it's not limited really. You can scale up, and we guarantee that as you scale up, the queries, the operations will continue in constant time. They're not going to be slowed down because of that. So it'll scale up as you keep going. Let's keep going. There's also a nice demo. Maybe that link will be shared also later on, where we have a number of these demos for you to use. And you also have one for hyperscale, used in an example for gaming, because when you go about gaming, you have these massive ups and downs of demand really. And hyperscale is a great tool to really accomplish this. Yeah. Lastly here, the serverless database option. The reasons are clear. Sometimes you just don't know what your requirements are, also in the future, maybe unknown. And you always want to really have the sufficient capacity and not be worried about, for example, let's say you have an elastic pool and it's still not the right elastic DTU to really fit everything inside, which could actually happen. And obviously, it's important to manage the unpredictable workloads. And that's shown here, what I've changed here with the serverless tier. You see like the performance graph here, number of vCores. This is only available for the vCore model. And it's used going up and down. You will be built for the maximum here. As you can see, here it's 4 vCores. So you're getting built even if you have fluctuations and the consumption goes down again. So not ideal. However, with serverless tier, that's the reason for serverless tier. As you can see here, it's still, we have indicated a minimum 1, maximum 4 vCPUs, sorry, and the load is still the same up and down, but now you're only paying what you actually use, and then if you don't need this database service inactive for a given period that you can define, it will then stop billing. So it would be sitting there, and you can wake it up with an instance really, because it's an Azure service. You can just restart, it'll come up again. That's serverless. Azure SQL Database Serverless. That's why it's the same idea as I mentioned, running Azure Logic Apps, Azure Function. Yeah, they are producing Azure consumption when you use them, and if not, nothing. That's there. You can use them whenever you want. So it's a great evolution, I think. Okay, if I don't see any more questions, Daniel, I will proceed to a demo. I think have a good time.
We're excellent in time.
Yeah, okay.
All perfect.
Perfect. Okay, because there I need to change my screen here, of course. Okay. So I hope you can see. Of course, I'm now inside my Azure virtual machine. You can see that, yeah, Alexander? I'm on, yeah.
Yep, you're on.
Good. Okay. Of course, what do we all do? Working with SQL and other databases, we love to deploy to an Azure VM right away. We call it a sandbox. So it is really a SQL database that we are going to look at, deployed here on this virtual machine. And in order to prove that, of course, yeah, I'm using the familiar tools. On the taskbar, you see PowerShell. Now, don't leave home without the PowerShell. And here we have I guess you know the answer. It's our friend, SQL Server Management Studio. And I will just go inside my virtual machine. You can see this is just worked inside my machine. I get to the other one, which is an Azure SQL Database later, and connect. No surprise, you see what you would expect. Okay, we do have a database. Wonderful. All right. So, and then once we have done this, okay, let's look outside. That was the other example. I am connecting to this Azure SQL Database. Always has the suffix database.windows.net. And you can choose the login, either in this case, SQL Server authentication. Here it's coming up. Great, looks pretty good. And then looking inside, that brings me to the actual demo. I see also, no surprise, we love working with AdventureWorks. And I've taken on purpose an older version. You see, a backup from AdventureWorks database for SQL 2008 release 2 on purpose. Because why? Yeah, that is the other part. Because I also have this new friend. I hope it'll be your friend, or it'll become your friend, the Data Migration Assistant. Can only recommend you start and use it. Of course, it can download without any cost. It will help you really making the first step. Okay, let's start here. I hope it's big enough, otherwise I can just go bring it up. It has two modes of operation. With this, you can access your SQL servers on-prem or here on a VM. It's the same assessing in the sense of differences between compatibility levels as you are on the way of upgrading SQL servers, because you don't want to and you cannot really move a SQL Server 2012 to Azure Cloud right away. So you would need to upgrade to at least SQL Server 2016. Okay, I'll give it a name. Bootcamp, das ist dann jetzt sehr test, okay. So you have my SQL Server. Let's stay here on the SQL Server, because we're not migrating yet. So create, and here we have those two possibilities: compatibility issues and feature parity. We don't have here. So yeah, because I know why. Once again, because I'm already on SQL Server 2017. That's why I will do this. You'll see why. Now I also have the compatibility check and the feature parity. Let's see what happens. Of course, connect to my source database. Yeah, here it is. I could have done the same thing really by going to of course to a SQL Server 2008, which I'm not doing here in interest of time. Yeah, okay. But you can see the compatibility level. That's 2008. Okay, start assessment. Ta-da! Here it goes. And I would recommend you also trying this out, where you see first the feature parity. So what has changed here, going to 2017 and to Azure SQL? Yeah, as you can see, one detail: cross-database references are not supported in Azure SQL Database. So database links are not supported, but it gives you a workaround it here. Using, of course, or to be expected, Elastic Pool to connect various databases, really, will produce the same behavior that you would have on premises with cross-database references. Compatibility, let's check out that. You can see here, you can test it out. If you go down to compatibility level 100, which is SQL Server 2000, you can see what has changed. So you would need what you would have to do going forward. There's just one behavior change, that's all. But otherwise, sometimes I would see which features have been deprecated. For example, send mail. That was a feature in 2008, for example, has been deprecated. You would see that, but it's not here found in my AdventureWorks. Okay. That was the first test. Good. So we are happy. Nothing really will stop us. So now I will migrate with data, schema and data. Just to show you how easy that is. You may not have to wait, but just to get you started. That's source again. Ta-da! Also could it's supporting encryption and server certificate, which I don't have here in my demo environment. Okay, next. Now my Azure SQL database, which is this one here. This one. I have two. Here it's actually I was using a different authentication with encryption. Okay. There are two databases here inside my Azure SQL database instance on Azure. One with level compatibility level 130. That is SQL Server 2016. And one with compatibility level 140, which is SQL Server 2017 compatibility level only, which has been created just as I was creating this new database. So you see, it's just happening as you are working with Azure SQL database. So no need to upgrade and everything. Changes and releases are reflected automatically as you move forward. And you would also see 2019 and so forth with the same SQL compatibility. So you can just move it. That's the beauty of deploying SQL database on Azure. Just working on the important things on data and applications. Yeah, I think I don't need to really go any further, but you can now select what you want to migrate. Here, source database, AdventureWorks, left side. In my database, it could be on-prem, but here it's in my Azure VM, and it will be moved to this database here on Azure SQL Database. Yeah. would give me an opportunity to just maybe stop and ask for questions, because this will take approximately 5 minutes to complete the migration, but I can show you the result at least after this step in the interest of time. So let me just open this one here. Because obviously I've done this before. So one select here in my Azure VM. Ta-da! It's a demo app. You know that, employees, blah blah. Wonderful, works great, good stuff. Okay, now let's prove the same thing. Going down, this is the Azure SQL warehouse database here. I've done this before this Azure Bootcamp, so, and you would have seen the same result with my demo right now. My colleague Sasha will tell you more about Azure Synapse later on. I'm always making that labs employees. So that's the proof. This is working, and it wasn't difficult. So we have just moved a SQL database with the tables, everything, to Azure SQL Database, and we're working with the same tooling that you're familiar with. The same would work also with application code and Visual Studio. When you're of course using SQL Server data types, way to go. And I think I will be bringing this to the end of my presentation here. Okay, let's see.
Okay, thank you, Bernhard. I guess, Sasha, now it's your turn, right?
No, next is Mark Römer, actually.
Okay, right.
But one last slide here, just to let it sink in. What I was showing was really how to start a journey from your SQL Server on premises. And if it's not SQL Server, we also have tools to deal with migrations, if anybody is interested. Also with automated analysis called the SQL Server Migration Assistant, just to mention it here. Once you're on SQL Server, you can bring it up. I've been using the Database Migration Assistant, which really is strong because of the compatibility discussion and recommendations, and then you deploy. But everything else can be done also from inside the Azure portal, and there we have a service, the Azure Database Migration Service. So it's almost like bringing data from SQL Server database to Azure. And my next speaker, Mark Römer, will show also what we do really in order to bring source data to Azure with another service which is called Azure Data Factory. Thank you. I'm handing over to Mark now, and thanks for your time. You can take over, Mark.
Great, thanks, Bernhard. This is Mark Römer. Give me just one minute here, everybody. I'm just getting a few things together here on my screen, and then I'll share my screen with you. So I'll give everybody a minute to sort of take a quick break, get something to drink, or take a bio break, whatever fits your need while I finish getting everything together.
I'll take your time.
And I should be sharing in just a second here.
Yeah, please feel free to make questions or comments or whatever, or if you want to see something in the team chat. Thank you.
Okay, so I think I've got everything pretty much where I want it to be, so I can get started. So we're going to start the session now on Azure Data Factory. So my name is Mark Cromer. I'm the Principal Program Manager responsible for Data Factory. I'm coming to you all live here today from Redmond, Washington. From my side of the great ocean, good morning to everybody. And it's great to be here with you all. So I'm going to talk to you a little bit for the next, I think I have about 30 minutes. Or 30 minutes plus to talk a little bit about ETL in the cloud and what that means in Azure. I'm going to go into my slideshow mode in just a minute. I just want to, sometimes when I share slideshow mode, I lose my context with the teams. So let's see how that works out. So let me just stay on the slide for a quick second. I'm going to give you an overview of Data Factory. Now, Data Factory, like I said, is the Azure ETL and data integration tool in the cloud. And so it's a platform as a service, which means, as you were listening to Bernhard talk about SQL, Azure SQL and SQL Server in the cloud, and the different modes that we have for that, think of this as that sort of serverless mode. ETL is basically serverless. We have some components I'll talk about with ADF where you can have components that live on-prem and in your VNet enabled VMs so that you can connect into your private data and into your on-prem data as well. But primarily Data Factory is going to be a serverless ETL tool. All right, so let me switch this guy into in slideshow mode. Let's see how things work out for me here. Okay, so let me do a few slides and then I'll go into a couple of demos and probably back and forth a little bit to kind of keep everybody sort of on the same page as me if you haven't experienced Data Factory much in the past. What I'm going to do in this for this next half hour is I want to talk to you about how you modernize data warehousing. So we talked about SQL Database, and then after when I'm done, we're going to talk about Azure Synapse. And I will tell you that I do struggle a little bit in calling it Synapse. I always want to say SQL DB, but we know all what we're talking about. So if you hear me talk about SQL DB and Synapse, I'm using those terms interchangeably. That's just me having a hard time changing my ways. But the bottom line to what we're going to do here with Data Factory is we're going to take data that is originating most likely in Azure SQL Database. We can talk a little bit about using a common frame of reference. We're going to talk about the AdventureWorks data that you saw in the demo just previously. And what you want to do with that, when you want to get it ready and prep that data to put into your Synapse analytics or your data warehouse, you're going to want to take that data, which is most likely going to be transactional data, right? It's going to be OLTP data. And you want to form that data into the best available mechanism or the best available shape to be able to report on it and have world-class analytics so that you can make great business decisions. And to do that, you're going to need an ETL tool. And that's where the Data Factory comes from, and that's where we are and where we live within the Data Factory team. So I want to talk to you about this modernization of this data warehousing. Azure SQL being a cloud database, Azure Synapse Analytics being a cloud data warehouse with also a workspace capability that includes Data Factory pipelines and data flows. And how do you make that all work, and how do you start to get started with this? So I'm going to assume sort of a baseline with Data Factory where you may have at least, you're here and you're listening to me talk because you're interested in how you do modern data warehousing in Azure in the cloud. But I'm not going to make any assumptions that you are very, very well versed in Data Factory. So this is going to be a bit of a starter kit for Data Factory today. So basically, there's a couple of primary reference architectures that we support with Data Factory that you would want to look at leveraging for your modern data warehouse. And let's start here with this one. This is a very, very common, very typical reference architecture where you have massive amounts of data from varying sources and formats. And those can be on premises, like I said earlier. They can be cloud. That doesn't have to be Azure. We can connect into AWS. We connect into Google, other clouds, other SaaS providers like SAP and whatnot. And IoT data all those different data points, and you bring those into Azure through Data Factory. Data Factory is very, very good at data ingestion. And then you prepare and transform that data. So we have built-in data transformation engines through wrangling and mapping data flows, which is essentially data prep and data transformation at scale. You notice that we have a call out there for Azure Databricks on this slide, and that's because part of that transformation engine that's built into Data Factory is running on Spark and running on Azure Databricks. And then what underlies all of that capability and data sharing within Data Factory is Azure Data Lake Storage Gen 2. And so we also have a lot of customers that build their analytics and their data warehousing ETL using blob store as well. But ADLS Gen 2 is essentially the more modern way to go with that. What you do with that then is you stage your data, you perform ELT sort of transformations and sort of patterns, and then you push that into your Azure SQL database, or what within the Synapse is now known as Azure Synapse SQL pools. And then at the end of the day, you're going to then take that those world-class analytics you've built, and you're going to make them available to your business to make decisions through Power BI. Okay, so let's use that as a frame of reference. There's one or two other scenarios that are very common with Data Factory. I'm probably going to just kind of brush over these a little bit, just because they go into other details I'm not going to talk about today, which is, we have a very rich SDK, so that if you don't want to use the Data Factory UI, user interface, in the browser natively, you can always build your own applications using our SDK. And we have a lot of customers that do this, but not the topic for today. This will all be in the slides, and we're sharing the slides so that you can take these and you can have these to reference back later. But there's another third very important use case that's very common with Data Factory and ETL in the cloud, which is to lift and shift your SSIS or SQL Server Integration Services packages. Now, think about this. When you were listening to the discussion from Bernhard on Azure SQL Database, a very common scenario is that lift and shift, that taking your SQL Server on-prem and moving into Azure with that data and with all of your assets that you've built for that data warehousing, that OLTP environment. And many times it's going to include the ETL that you've built in SSIS. So in the team that I'm in, the product team I'm in, which is Azure Data Governance, that's the Uber name for our team, we also have the engineering and the program management for SQL Server Integration Services. SSIS is in our team as well. So we essentially own ETL and data integration all up at Microsoft. But what happens is when you lift and shift that database into Azure, you need to find a way to also either rebuild or port your ETL into Data Factory as a PaaS service, or you can lift and shift those SSIS packages. So we have full end-to-end capability in Data Factory to take those SSIS packages pretty much as they are. There's going to be some changes that you'll need to do, and we have a lot of documentation that will walk you through all the different nuances and things you need to know to do that porting from on-prem to the cloud. But you can move this SSIS packages into ADF. ADF will then execute those packages. That's a very good way to get started, by the way, in the modern data warehouse. You're lifting into Azure SQL Database, into Synapse DW, and you have to get your ETL into the cloud. And so, ADF using SSIS is a great way to get started. And then you can start to rebuild or greenfield your new ETL packages natively in Data Factory from that point on. Okay, so let's talk a little bit about what you're going to get. So when you open up the box and you begin building your data factories, and I will show you, by the way, how to open up the box and how to get started in the portal. What you're going to see is you're going to have essentially these 5 sort of pillars of functionality within Data Factory. You're going to be able to ingest data very, very fast with native connectors. We have almost 100 native connectors to different sources of data, not just the SQL database and SQL DB we're talking about today, but also storage accounts in Azure, on-prem, Sybase, if you want to use Sybase. I did not mean to chuckle. Sybase, Oracle, SAP, on and on. And then once you've ingested that data, you're going to want to build some workflows around that. They're very common then to take that and to have an execution of that integration that is conditional and incremental. And so you want to build some workflows around that that ingestion, and that's through what we call control flow. So you're going to build what we call data pipelines, and control flow would allows you to do things like build conditional execution, looping, branching, all those sorts of functionalities are there. By the way, if you're familiar with SSIS, the SQL Server Integration Services, a lot of these things should be very, very familiar to you. A lot of these exist. I mean, these are ETL tool constructs, right? These, if you're already performing ETL, you're familiar with data warehousing and analytics, these things should all be bread and butter to you. The next thing that you do is data flow. Now, data flow within Data Factory is a little bit different, probably from what you're familiar with traditional on-prem ETL tools, in the sense that data flow is built from the ground up with Data Factory as a scale-out data transformation engine, and that's where we use, like I said earlier, we use Databricks and Spark for that, and that allows us to be able to take your runtimes, essentially your Azure integration runtimes, and scale those out to end scale, so that you can take your transformations and don't have to worry about aggregating data across 100 rows today and then 100 million rows tomorrow. We scale to all that different size of data. And then scheduling is built into Data Factory, just like in SQL Server. You would think of those as from the traditional, sort of scheduling through SSMS or through SQL jobs. You are essentially going to schedule those through ADF. So your SSIS that you've lifted and shifted, your Data Factory pipelines, transformations will all get scheduled through ADF. We have a scheduling mechanism built in. And then you monitor that. And so I'll show you some of this, the monitoring capabilities through a demo. Now, Data Factory is a natively, I kind of hesitate to say code-free, just because there are lots of things that you'll probably want to do and like to do through coding within Data Factory, but it's a low-code environment, and it is browser UI driven. And so there's 4 different sort of primary user interfaces that you're going to interact with in Data Factory. So let me start from the left and go to the right and then the bottom. So in the orchestration piece in the top left, that is essentially the control flow where you're building workflows that I was talking about earlier. In this case, we have a bunch of data ingestion. The left-hand side of that the diagram, the top left, is copy activities. And those copy activities are ingesting data, probably taking some data from on-prem, maybe AWS, maybe storage accounts, a SQL Azure database table. Taking that data and you're landing it. In most cases, like I showed in the reference architecture diagram, that's going to be a common area, like in ADLS, a staging area. And then in this case, we have a bunch of Databricks notebooks that are performing some actions on the data, some data prep, some other things that are going on. Maybe we're doing some machine learning modeling in there. And then we're doing some data flows and some more copy on that. I'll show you some demos where we include some data flows in that workflow as well. And then the next 2 screens are the data flows. The first one is the mapping. This is the ability to do data transformation, where you are thinking about the way you want to do ETL from a logic first perspective. What I mean by that is, you want to aggregate data, you want to calculate some columns, you want to join some data and do upserts, right? So you're going to design that from a graph perspective in that construction diagram in that middle screenshot. And then on the right-hand side is more of a sort of interactive, a wrangling interface, where you're doing some data transformation, but it's more of a data prep environment. For those of you familiar with Power BI or Power Query, you'll notice that interface. That is actually Power Query Online, built into Data Factory, so that you can take samples of data and you can transform it by working with the data as data first. So mapping data flows logic first, wrangling data flows is data first. And this will allow you to build transformations and execute those at scale. So if you like the Power Query sort of model of working, the interface, the Excel style interface, but you're used to using it on your laptop and it doesn't necessarily scale its sampling of data, this will allow you to take those Power Query data prep modules, essentially those data flows, and run those at scale. This will execute on Spark as well. So it's scaling out those Power Queries. And then at the bottom is your rich monitoring. So this is a lot of very intricate work with data and with workflows, and you'll need to have a good monitoring experience. You need to be able to make sure that your data is landing every day in the format that you expect. Your aggregations are completing. The reporting data that's landing in SQL Synapse DW. So I can just keep mixing up those terminologies into your data warehouse. I'll just say it that way. At the end of the day, is in fact completing successfully. So we have a monitoring experience. All these UIs are built directly into Data Factory. So what does this enable for you? I talked about these already. This enables for you the ability to modernize, take your SSIS workloads into the cloud, rebuild those in the SaaS applications we're not going to talk about. So in terms of ingesting all the data, you're going to point to what we call data sets. Those data sets define the data that you're going to bring into your databases and take out of your databases. And Data Factory does not store any data. It just moves data and transforms data. I'll show you the connectors on the demo. This is an example of sort of a workflow and what the workflow would look like. So this is not, of course, the UI, but this is a conceptual diagram of, in this case, taking some data from Data Factory, doing transformations through Synapse, loading some data, or querying some data out of Snowflake, and then using the ADLS Gen 2, in this case actually Blob Store, but you could replace that with ADLS Gen 2 in most cases, as a common storage layer. And a lot of the transformation in this case is done through Azure Functions. Azure Functions is also a very common mechanism to use in Data Factory to perform actions on your data. Data Factory does not store data and has a transformation engine that's on Spark. But if you have some code that you want to write in .NET, you can use Azure Functions to do that as well. Now, once you start to build your transformations graphically, they will look like this construction diagram that you see on the screen right here. This is a mapping data flow, and this is data deduplication. So a very common thing to do is to perform data quality in Data Factory. So you've got a lot of dirty data, a lot of data that's not cleansed yet, that's coming into your ADLS Gen 2, coming from your many different databases in Azure SQL Database, or landing from files, and you need to join that data together through fuzzy lookups. You need to normalize some of that data. You need to do a lot of trimming of data, a lot of maybe mapping to common codes, or take codes and map those to strings. That's all part of data transformation in Data Factory. Now, managing your slowly changing dimensions. So as you're going to load and you're going to look at SQL DW and Synapse pools, you're going to want to build your star schemas and your dimension data, and you're going to want to manage that, right? Those dimension members, those rows in your dimension tables are not static. They change over time. You need to have a strategy in place to be able to manage those. And we have templates built into Data Factory to do that. And actually, I'm highlighting a template right there. In fact, this screen over here is Data Factory templates. These pipeline templates are out of the box for you to be able to get started building pipelines without needing to learn the entire platform from scratch. Just use these templates. This is slowly changing dimension type 2. We also have type 1. To go back to that data deduplication, we do have 2 dedupe. Actually, apologize. I meant to say we do have 2. We're just not highlighting in this picture. I got to fix this picture. But we do have the dedupe pipeline template as well for you. And then, of course, you need to load that star schema. You need to load both the facts and the dimension table. So here's a fact loader. Fact loader is a little bit simpler than slowly changing dimensions. But we do have handling within the fact loader pipeline template so that you can also account for things like early arriving facts, whereby the dimension has not been written and there is no dimension, the dimension surrogate key lookup fails. So you can pre-build that dimension with a holder value for your surrogate key. I mentioned fuzzy lookups, so if your data is coming in that's not cleansed, you need to find a match, a surrogate key, but it's not an exact match, so you do a fuzzy lookup. Okay, I'm going to stop there and go over to the demo. The slides go on for, I made it through 17 through 48 slides, so there's lots more material. We'll upload the slides so you can have a look and you can go through the rest of the material. But what I want to do is I want to go over into a demo. I much prefer to actually show you some of this in action. I think it's a lot easier for you to understand. So I promised you to show you how to unbox your data factory. And so how you do that is you will want to go into your Azure portal. So this is my Azure portal. It looks a little bit different than yours. This is the internal portal for Microsoft, but the basics to what you're going to do to get started with Data Factory is to first create a factory, and that's essentially creating an account for Data Factory. So you're going to want to go to Create Resource and just look for Factory, and you'll see Data Factory. There we are. And then you can click Create. So you go through, answer a couple of questions. We don't have a lot. Just give us the location. I always strongly encourage you to enable Git integration with Data Factory. So Data Factory natively, as long as you set this, out of the box will come integrated with Git. So we support essentially the Git's methodology, the process, to be able to have CI/CD processes, to be able to have save and recover, rollback, all those sorts of mechanisms with your source control within Data Factory. Now, so just enable Git. There are two different types of repos that we support. We support Azure DevOps and we support GitHub within Data Factory. If you don't select this, the downside to it is you can still work with Data Factory, but what happens is because we're a PaaS service in Azure, every time you make a change to your factory, that has to get published directly to the live service every time. So it's essentially writing code directly against a production service, which is never a great idea. It's supported, but it's supported, yes, but it's not a recommended. It's not a best practice, in other words. Okay, so enable Git, go through these questions, hit Create, and when you do, you'll then have your Data Factory. I'll show you one of my factories within the portal. Actually, no, I'll just go to my dashboard because I have it pinned on my dashboard. And there you go. So you get a few monitoring charts and tiles directly in the portal. And then you click on Author and Monitor. When you click on Author and Monitor, you will launch into the browser UI for Data Factory. It looks like this. So to shorten the time to demo, I put together a couple of real quick and easy pipelines for you. Now, the way that I recommend you getting started, we have a couple of tutorials. Let me quick go into my into the docs online for Azure, and I'm going to show you. If you go into the docs for Azure Data Factory, the Azure Data Factory documentation, you will see a series of quick starts. We do have some documentation with tutorials, and we also have a whole tutorial section as well about copying, transforming, the control flow piece, and SSIS. We also have a couple of labs on here as well. So this is some great sort of self-learning or self-paced learning for you to get started. But also back on Data Factory, what I really like is I like for you to go to templates. So the layout of the UI is such that your graph and your working area where you're designing your ETL and your data ingestion in your factories and your pipelines, that is over here in the design interface. And that's the top section here. And the bottom section is essentially the feedback pane. You'll use this to configure your activities, what are known as activities, and then you'll tie those together through different types of conditionals, such as if it completes with success, failure, just on completion, or skipped. So by the way, which reminds me, as I mentioned, that you do have the ability when you're building your workflows to be able to debug these and to be able to say debug until. So it's a very rich dev environment built into your browser. We are espousing the idea within Data Factory of a purely PaaS zero footprint service, so you don't need any client tools to work with Data Factory. So when you're debugging, you see I ran this debug earlier this morning. When these different steps are completed, you get monitoring of those. So this is my copy activity right here. This copy activity was bringing data into Azure. And if you look at my, actually I was going blob to blob in this case. So if you look at the eyeglasses, you'll get the details of your copy, of your data ingestion. What was your throughput? How many connections we used? Number of rows written, the size of the data, and the time that it took, and that is all available to you. And you can see that it did complete. You see that it was successful. Then I have a data flow right here, and inside of this data flow, I am I'm transforming some data for data quality purposes. And if I click on that, I get the details of that execution. So it took 4 seconds to filter rows. I had to filter criteria on there. I had some aggregation of data that took down to 42 milliseconds. This all runs in memory in data frames and Spark, so it's very, very fast. In fact, what you can do additionally is you can click on the different, you can look into the different transformations. In this case, these tiles are transformation tiles. When you click on them, you can see the details, such as how many columns there were. So now when you're in transformation, you're much richer, deeper with data. So the detail is much finer. You're no longer at that that broad grain of monitoring. You're now looking at how many columns, how many rows, how long did it take to do this, and how many partitions were used for that data, right? Everything here was done in one partition. It's a very, very simple example. But if you have, instead of 9,000 rows, if you have 900,000 rows, now because this is Spark, this will be able to expand the number of partitions out to 200 partitions, 2,000 partitions, whatever it may be. Okay, that's just rich goodness that I love to show, so I kind of jumped the gun a little bit on that one, went a little bit ahead of myself. What I was trying to get to was how to open the box. So I showed you how to get the box through the portal and how to have a factory. Now, how to start building within your factory once you've unboxed that portion is to start here under Factory Resources. All of your resources are here on the left-hand side. Okay, so they're going to be listed under Factory Resources. The primary high-level first-class resources in Data Factory are pipelines. This is a pipeline here. This is essentially where you build your workflows. And this is where you have capabilities such as your iterations conditionals, your for each, if condition, switch until. Your transformation and your data ingestion is here in the copy and the data flow. I mentioned Azure Functions as a way to be able to integrate with your .NET code. You have Databricks, HD Insights, and you have custom. So you glue these and attach these together to make a workflow that fits your ETL needs. Okay, and then you debug, and when you're done debugging, you make a trigger. Your triggering is your scheduling, and you can set that to run, every day, every 3 days, every hour, whatever that cadence happens to be. You totally set that. So that's pipelines. Then you have data sets. So I was talking about this earlier, data sets. I promised to show this to you. So let me show you. So data sets are how you define what your data is going to look like, the shape of your data for Data Factory. And by the way, your shape of your data does not have to be static. This can be dynamic. This can be parameterized. And you could say no shape. You could just say, I have data that is in Amazon Redshift. And whatever number of columns are in that table today, I want to intake all of those. Okay, so it's very, very flexible within Data Factory. But this data sets define the data, and then what defines how to connect to those sources is called a linked service. Okay, the linked services are going to be available here under connections because that is a connection. So this is the management hub within Data Factory, and this has the details of all the different parts of your factory that include connections. So linked services, you'll see the same kind of pattern here when I'd make a link service. By the way, this is where you see those 90 plus connectors. We have connectors for Azure Blob, for Azure SQL Database, the Synapse, all the different connections, Dynamics, SAP, so on and so on. So this is a continually growing set of connectors that we give you a Data Factory at no cost. These just land in your service, and these we maintain these, we grow these, so on and so forth. Okay, integration runtimes. Integration runtimes is how you tell Data Factory where those data sources live. So they can be on-prem, they can be through SSIS, they can be in Azure. Use the Azure Integration Runtime to define that. You also use Azure Integration Runtime to define the size of the compute that you want to use. So I was mentioning earlier about the scale within Data Factory. So you could say that, I have data in a database that is driving my business. My business completely depends upon millions of rows being changed every day. So I need 64 cores of memory optimized compute every day. And you can set that here within Data Factory. So all this is available to use inside of Data Factory proper without needing to go out to external engines. If you want to maintain those external clusters of computes, you can do that as well. That's just the hand coding way of doing things. So that's the management hub. Let me go back into the authoring piece of Data Factory and finally get to what I've been trying to get to, but I keep sidetracking myself, which is that a lot of this sort of existing pipelines is available to you through templates. So under Factory Resources, go to New, Pipeline from Template. Now you're going to get an entire set of pre-built pipelines. Okay, anything from bulk copy from any database to Azure Data Explorer. We have incremental patterns in here, very, very important. So if you're incrementally copying data, just deltas of change data day after day, you don't want to try to import an entire database table. So we have incremental patterns in here as well. By the way, those incremental patterns, they actually have one up here. They look like this. They give you the ability to look up versions, right? This is, in this case, this pipeline is leveraging the built-in SQL Server, Azure SQL database capability of change tables. And so we just read the last version of rows, and we're able to then get the through incremental copy, you're able to get the latest changed rows. And then what you do is you run a stored procedure. So there's a stored procedure activity within Data Factory, which is linked up to your database. So you point to where your Azure SQL database is, and then you just point to the stored procedure. And you can, in this case, I typed it in, so I clicked edit, but we're also able to query out into your database and find all of these stored procedures, stored procs in your database, and you just point to it here in Data Factory. Data Factory is the centralized orchestrator of actions in Azure Data. Now, after I've updated my change tracking, I can then go and run some data flows. So now in this case, I'm deleting some old rows. In this case, I'm masking some data. So data masking is a very important function within Data Factory that we do with data transformations. We say, this data before it lands in my analytical schema, in my star schema, I need to mask any PII or any information that's going to land in there. Okay. So I think I have about 5 minutes left, so I'm going to try to hurry up just a little bit. So let me go back to those templates. In the template gallery, pick whatever you'd like from here. I'm going to show you as a last sort of demo, I'm going to show you some of the data flows. So if you click on Transform with Data Flow, you will see some of those templates in here. There's that dedupe I mentioned earlier. This is the second one. So I was saying there's two dedupes. There is another one that's called distinct rows. Much simpler than dedupe. Dedupe pipeline is very complex. It has fuzzy lookups, got fuzzy logic. It uses, I believe it uses both Soundex and Levenstein algorithms for that. But that's all available to you. You can look at that and you can play with it. There's the fact loader. We have the ability to, let's see what else. We have some analytics examples. There's a slow change in dimension example. So if you click on this, it'll show you how to build a slow change in dimension. All you need to do then is take that pipeline and change the data sets to point to your data and your dimensions that you are managing through Azure. Okay, so let me go back to this pipeline here. And this pipeline is really just bringing in some data, running a stored procedure. Notice how I have both a path of success and failure. So if this data ingestion fails, I will then just run a web activity that probably calls a REST API that maybe just sends an email or could update a flag somewhere. If it succeeds, I'm going to run a stored procedure that maybe pushes some data from one table to another, and then I'm going to run a data flow. And here's what the data flow looks like. So now the data flow is a slightly different UI because we want to make sure that you have a different sort of visual context. You've now gone from building workflows to building deep data understanding, data transformations, right? And so in this case, I'm pulling in some data. This is for my movies data, my movies table. And actually, let me go over to one that I have. Actually, I should have one that's running. Yeah, let's go here. So this is a data flow that does a join across different tables within Azure SQL Database. And so here I'm pointing to an Azure SQL Database data sets. Let me actually open that up for you. This is loans data. So this is what a data set looks like. A data set has that connection to your database in this case and has all the different tables available to you. I could also work with views here as well, but I'm looking at my loans data within this data set. What we can do then within this data flow is we can do things like we can take that source of data and we can we can join that, we can union, we can do a SQL exists on it, derive some columns, aggregate it. What I'm doing here is I'm doing some aggregation on that. I'm doing a bunch of aggregations actually. I am sorting by the grade, which is the grade of the loan within that sample sample loan data in a bunch of different aggregations. I am summing the data. I am pulling out the first ID from that data. And what happens when I do that is you can actually work with that and visualize that data natively, directly, interactively within Data Factory. This will actually go out and this will pull the data from that data table, from that data source, and will give you a sampling of that data. So when you are working with data flows in Data Factory, you can actually sample data, and you can. This will allow you to ensure that the logic that you're building with your data flow is actually correct. And this looks pretty much right. These are the different breakdowns of different grades. I remember I had my aggregation grouping by grade, and then I got a total amount and the first ID from each of those. The reason why I'm doing first ID is I can then join this data back to the original data. So my join here is going back from the aggregated data on the left to the original data on the right, and it is joining on the ID column. Once I do that, I can do a derived column. The derived column, I'm sorry, this is actually a select, so I could do a derived column next. A derived column would let me do things like do something like take an existing column like that. Let's take that grade, for example, and let's say I don't actually want that to be shown because I need that to be hidden from the business that will be using these reports through Power BI. So what I could do is I could hash that. I could do, for example, I could do a CRC32, I could do a MD5 on that, and I could hash that column. So I could say hash that grade column right there, and that'll then mask that field. And that's a derived column. You can create new columns. You can update existing columns to the derived column. Now what I do is I sync that into Azure SQL Data Warehouse. This would be a good transition point. So I choose an Azure Synapse Analytics table for my targets. I map my fields. I'm doing auto mapping. I'm letting Data Factory do that mapping. And then when I refresh this, you'll see what the data looks like once it reaches that database. And one thing I wanted to quick show within Data Factory is the way that you make these data flows is you're going to go to New, and I believe my browser just froze on me. Oh, there it goes. Now it's back. You're going to go to New Data Flow, and you'll get those two different options: mapping for building those logical graphs I'm showing, and wrangling to work with data first in the spreadsheets format that I showed earlier. So let me quick go back to this. I should see my results. There we go. So there is all the data that is joined back to the original data. And you'll see the amounts with those first IDs for the aggregations right here. So there's a peek at your data with 1,000 rows. This data has about 1 million rows in it, so you can work with it interactively in your browser within Data Factory. Okay, I think I'm pretty much at the end of my time. So what I'm going to do here is I'm going to quick stop my sharing. And let me just quick see if there are any questions. Otherwise, I think we're ready to hand off to the next presenter. And if there are any questions, I can always just answer questions in the chat as well. So thanks, everybody. That's pretty much it for me for Data Factory.
Thank you very much, Mark. Was an awesome demonstration. Thanks a lot. And I guess it's time to jump over.
Sasha is next. Yeah. Great.
Well, let me give that a try. You should be able to know you don't see anything. So let me stop screen sharing. Once again. So, are you able to see my screen?
Awesome. Yeah.
Perfect. But let's start, hopefully also with
Screen.
PowerPoint. Perfect. So I prefer to have, let's say, demo-based sessions. That's why I have only one slide. I'm not talking about the first and the last one, but the one in the middle. So I would like to talk about Azure Synapse Analytics. And Mark already said that we renamed SQL Data Warehouse to Azure Synapse Analytics. And I'm not quite sure if we did a great job with that, because we also introduced our completely new platform with the name Azure Synapse Analytics. So that's why I'm not talking about formerly SQL Data Warehouse. I'm only talking about the new functionalities which come with that beta. And to be a little bit more precise, I decided to add one single slide, which gives you an overview of what we do and what we want to achieve with Azure Synapse Analytics. Because as you saw, and oh, I figure out there's an icon missing. But anyway, if you think about what we initially had, we had MPPs, or multi-parallel processing database or data warehouse solution. And you saw already Mark showing the data integration part, so getting data into that system or into any of those systems. And what we want to achieve with Azure Synapse Analytics is a little bit more. We want to give you kind of a one-stop shop where you get all your data analytics into one space, one environment where you have the management, the security, the monitoring, and the meta store of several tools into one place. Which means if you look at the middle part of that diagram, and the grayed out box should have showed Spark. I don't know where that icon, probably doing copy and paste was gone, but anyway, we are showing you, or we are providing you several tools which fit into those four boxes. So what I'm talking about is provisioned SQL, which is still the formerly SQL Data Warehouse, now called Azure Synapse Analytics, or the SQL pools in the end I'm referring to. But we also want to add more functionalities. For example, an on-demand SQL, and that's one feature which I'm going to show in my demo. As well as when I'm talking about the Spark piece, we also have provisioned Spark, which is HT Insight, Azure Databricks, and so on. But we also want to provide an on-demand offering for Spark. I wouldn't call it serverless, but it's, I would say, time-boxed, and I will go deeper into those new functionalities in a minute. Surrounding those functionalities, so if you combine all those tools, you have those languages like SQL, Python, .NET, Java, Scala, and R. But if you combine those functionalities into one tool set, you also need kind of a new IDE, of a new management environment and development environment. And that's called Synapse Analytics Studio. And that's the tool which I'm more or less using throughout of my complete demos and pieces, which I'm going to show you. Underneath of those analytics tools, you still need some kind of storage. And that, again, could be either our traditional blob store or data lake store Gen 1 or Gen 2 to process that data. And that's something Mark already mentioned in his session. So that's about it for that one slide. Let's directly dig into the demos. And let me increase the size a little bit. Hopefully that's large enough, because I'm sitting at a 4K monitor and that might be a little bit tricky. So as you can see in here, I'm in the Synapse Studio area, and that's really representing those areas, ingesting data, exploring the data, and exploring could also mean that a data engineer is exploring the data, but also that a data scientist might look into that data, have it visualized in some ways. And last but not least, analyzing piece, that's where I will drop off. So I'm showing you only the explore and analyze pieces. Mark showed you the ingest piece, and the last session will be visualization. That's where I drop off. So I will only show you the middle pieces. So exploring the data, digging into the data, analyzing the data with different tools, and as I said, drop off for visualization. How do you get that Synapse workspace and that Synapse Studio? It's currently public preview, so you can sign up for that. And if you do so, let me increase that size as well, you get an additional resource you can provision in your Azure environment. And if I click on create a resource, type in Azure Synapse, you see that I got access to the workspace preview. And in here, I can create that. And in the end, like pretty much any of those resources, I have to specify a subscription, specify a resource group for my logical grouping, give that workspace a name, define which region that workspace should be created. And since all the data you use and store, not the data, but the metadata, will be, except for one piece, and I will come to that later, be stored into a central space, you need at least a data lake store Gen 2 as a starting point. From that, you can add and link more and more resources like Cosmos DB, like other storage accounts, and you will see that in a second. Then, of course, some security, networking things, hook it up to different networks. I will skip that because I have already a workspace. And in the end, a summary, and then I can start showing that. So I created one already. And let's dig into that workspace. On the left-hand side, you see several options like data, develop area, orchestrate. That's in the end Azure Data Factory, which you just saw, and then some monitoring and management pieces, which I will skip in for that demo, but I want to dig into the data area. So in the data, you see that several databases have been already attached in that workspace. Some of them are SQL pools, so the traditional SQL data warehouse pieces. Some are the on-demand pools I already mentioned. So really, in the end, you pay per query. And that's also an option to have databases or at least metadata stores, pretty much similar to a Hive metadata store, and you can sync those two into one space. Down here, and that's why I said Hive is also in there, since I can combine several tool sets, I also have Spark Hive, or in the end, Hive metadata pools or Hive databases in here as well. So I'm really in a cross-platform analytical space, and I can add further options like connect an external data, create a data set, which is in the end a data factory data set, and so on. And I also have, again, here kind of a tab view to have several tabs open to work around different things. I opened that just for testing purposes, so I can close that. And first of all, I would like to show you the capabilities of SQL on demand. Therefore, let's close the databases, go to linked, and see, and as you can see, I linked already 37 storage accounts, a few Cosmos DB things, but I want to dig into a storage account. So just imagine we used already Azure Data Factory, for example, to export from our on-prem systems, from our various cloud or on-prem databases, our data into one central data lake. And I will use the first account just for demoing purposes. So I can open that. That's a data lake store Gen 2 account. I've got various containers in there. Let's go to the staging container. So we pulled already data in. And let's go into navigating through that storage account, going into the students folder and going into the folder where 2 Parquet files are stored. So just imagine you exported that data, in my case, as Parquet files. What I can do with SQL On Demand, I can have a direct look into that system. So right click on that, select top 100 rows, execute that, and in a few seconds, that, I would say, serverless option spins up, executes that job, and as you can see, retrieves the data. I also have some visualization options like creating a chart and so on, but see the data of that file. And as you can see, the syntax is SQL, and to be honest, that's pretty much the same syntax you have in the SQL database space, which Bernhard showed, but we added a few tweaks to make it possible to use that as an on-demand service. One of those tweaks is we enhanced the open row set command, which means I can specify in that case automatically, more as generated code, it's specifying that in that storage account, the staging container, the students folder, the Parquet folder, and that Parquet file. And it's telling me that this is a Parquet file. But of course, I can add more things. I can use a delimited file format. I can specify what kind of delimiter are in here and so on. And that's what we added to that open row set. We also added some more functionalities into that. For example, you can use wildcards. I said I'm using the Parquet folders, and there were 2 files in there. So let's use just an asterisk, so picking any Parquet files. I got also decide I don't want to stick that to that folder. I would like to have a recursive query through all folders or through the whole container. So I think you get that point, that I can really use different wildcards and other functionalities in there to really make that a recursive query. So let's stick to only those 2 Parquet files to make that query not too complex. And as I said, it's kind of a T-SQL language, so I can add a where clause, for example, in there and decide that I want to use the CRM ID equals, or let's put an in query in here. So I want to select a couple of them, have that the 27, which I saw down here, and the one is 2055, for example. And since I'm querying 2 files, those will be, both files are pretty much the same values in there. I will get duplicated values, but that's fine for me. Just run it. So I'm querying 2 files. What did I make wrong? Oh, semicolon. Let's try that again. And I'm querying both files, and all the values I got from 2 files took me around about 2 seconds to really directly parse the underlying storage. It's not a SQL server. The main difference between SQL On Demand and a typical SQL server like SQL Data Warehouse or like the SQL database is that the typical SQL server has an internal storage. This SQL On Demand functionality is completely relying on outsourced, on outer storage systems like Blob Store, like Cosmos DB, and other things, which I can use directly in here. So what I could do in here is kind of a, I would call it data virtualization, because what I can do in here, I can store metadata in here. So I could create an external table, which I don't want to do, but I want to save that as a view. So create a view, DBO, my students, for example, and I can store that as an external view. Let's pick a database where I want to store that. Doesn't matter. Let's pick my demo, run that. And I created that external query or that external view. And now I can go in here and select star from my view, get rid of all that stuff because that is part of the view, execute that, and kind of in the end do a data virtualization in my metadata store, so in this case into my SQL On Demand database. That SQL On Demand database can be, and let's go to that workspace, go to that database which I picked, it was called my demo, open that, and as you can see, no internal tables, only external ones, external resources, which could be credentials, how to log into a system, For example, a blob account where I use shared access signatures to get that data out of that resources, my views, and that's the one I just created in here, as well as some schemas just for, yeah, more or less organizing my account, and of course some security credentials who can access that database. And as I said, this is a separate service, the same like SQL Data Warehouse, the formerly SQL Data Warehouse is a separate service. It's just combined into one system, which means, and that's why I want to go back to my Azure portal, go to my resource groups and just open the resource group where that workspace up here is located. And let's go a little bit down. Where is it? Oh, accidentally moved across it. Here we go, that workspace. And that's why the SQL on demand has its own endpoint. So what you can do, it's listening on port 1433, which is exactly the same port a normal SQL server would listen to. And you can connect with all the SQL tools, like the SQL Server Management Studio Bernard showed in his demo, to that endpoint to, in the end, query your external data out of that endpoint. So it's just one puzzle piece out of that whole Azure Synapse Analytics environment. And I said, as you can see up here, it's a SQL script number 17, which I automatically generated. And I said there is even more functionalities in here. So let's go to the development piece. You see that there are several scripts in here. The first ones are running on a SQL Data Warehouse, for example. So that's just a traditional SQL Data Warehouse I can run and use. And as you can see, connect to currently one SQL pool. So formerly SQL Data Warehouse is in here, as well as the SQL on demand, got its own databases and so on and so on. So the standard piece. But I said you also can run other systems in here. For example, a Spark pool, a Spark cluster. Let me just open that, just an existing notebook. And if you haven't seen Jupyter notebooks before, that's a typical environment which comes mainly from the data science space, because they want to run different cells separately and combine different functionalities into one document, which means up here, this is called a kind of documenting, so a markdown language cell. Down here, I've got another markdown language cell. Now I've got a cell, which in this case is a Spark, a Python command. So I've got my Python in here. Then I've got one which contains Scala code. Why do I know this is Scala code? Because the default language of that notebook is set to Scala. And as you can see, there are several languages in here. It's a preview. That's why currently R is missing. It used to be in the early stages. They disabled it for some reasons. I'm assuming this will come back. But in any case, you can set that to Python, Scala, and Spark SQL. So these are the typical Spark languages. But we also added .NET as an option. So you can write also .NET cells in here and use those into your space as well. So I accidentally closed that one. Let me open that a little bit. So in the end, I can run those cells independently, but all those cells will run into one context because that's the context of my notebook. And as I said, this notebook could, for example, connect to an Azure Databricks environment. But in this case, I'm using Spark pools. And what does Spark pool mean? I said it's kind of a serverless approach. What does kind of, in my case, mean? Let me go to manage and just create a new of those Spark pools, and you will see, no, that's a SQL pool. Get rid of that. Cancel. Pick a Spark pool, add a new one, and you will see what I'm talking about. Of course, I will data and AI hub, give that Spark pool a name. I can set it to auto scale, so 3 minimum up to 40 in that case, or I can, I don't know, 200. What's the machine size? That's typical, not serverless. I'm talking about really machines. How powerful is my Spark cluster? How many worker nodes does it have? But if you look at the next settings, you will see you can auto pause it, which means that if this runs idle for, in this case, 15 minutes, we will shut it completely down and spin it up if you run the next query. In the end, you can switch, choose a Spark version. That's really plain vanilla Spark with all those functionalities. And I get that question a couple of times now. Yes, Delta Lake is included. So it's really the Spark version from that on-demand Spark system, which is which we're using a plain vanilla Spark. You can use upload packages in terms of a pip or requirements file in here. And that's about it. You can specify some text and create a new one. I think this will, again, increase over time in terms of functionality, so that's more as a starting point. I don't need a new one. Let's pick one of the existing ones. And the thing with the Spark pool is, if you compare it to, I don't know, HD Insight or Databricks, that might take, I don't know, 5 minutes, 10 minutes, 15 minutes to spin up. What we did in here is a little bit, yeah, I would say a different way. So let's go back to that notebook, for example, and just run the first 2 cells. Execute that one. And you see it down here, it's starting a Spark session, which means currently there is no Spark cluster at all in there. So I'm paying nothing for it. But it takes round about 1 to 2 minutes. Then the Spark session is ready with my 3 nodes in that case. I can start with that. I can run my queries going in that session. And if I'm using that session, and if I'm doing nothing for 15 minutes on that Spark environment at all, it will be automatically removed. And again, I don't pay anything. So therefore, this is really, yeah, it takes around about 2 minutes. That's why I will move on and execute the second one. Maybe we can come back later to that functionality. But in the end, I can specify pretty much everything in here. I know Mark showed a lot of data factory things already, but let me go at least show you the main differences in here. So if I open that, I've got plenty of pipelines in here. Let me just create a new one. And as you can see, we integrated Azure Data Factory into that environment as well. And most of those functionalities are the one which are existing already in the G8 product, so in the publicly available product, like, for example, copy data, using the data flows Mark showed, and so on and so on. So you've got all those functionalities in here as well, but there are also some special tasks which are dedicated to that Synapse environment. For example, pick one of those notebooks I just showed you and make it part of my pipeline. Same for Spark job or stored procedure, which is tightly connected to, for example, a SQL data warehouse in here. So I've got more or less kind of, I would call it shortcuts, because if I search, for example, for stored procedure, you will see it twice. One is the special version of Synapse. One is the general version, which can pretty much connect even outside of that Synapse environment. It's just the first one makes it a little bit more easy because you have those already created links to the data sources in here. Let me have a look at my, oh, that's still starting. So the 2 minutes probably aren't over yet. So let me wait a few minutes before I come back to that topic. At this point in time, are there any questions? Otherwise, I would move on and have a nip of water. Okay, I'll call that a no. So let me give you a little bit more context around it. As you saw already in the management environment, you can create those newly Spark pools, but there's automatically only one SQL on demand in there, because you honestly don't need more. This is a plain container with your workspace for everything, but you can add more and more SQL pools. And as if you know what this formerly SQL data warehouse was capable of doing, this is pretty much exactly the same story. So I can decide the performance level. I can give that thing a name. Data AI Hub, DW, for example, got my additional settings, restored from a backup, and so on. So kind of a tightly integrated version in here itself. If you have worked with SQL Data Warehouse before, you can imagine that workspace as the formerly known logical server. So it's just one area where all those functionalities can be added into that, I would say, resource structure. But again, I can link various services. You saw that already in Mark's demo in terms of, I don't know, to a storage account, to, I don't know, various other things. I can, and this is more or less the part where Data Factory is in there. I've got the orchestration part where triggers and integration runtimes can be added. I've got a currently pretty simple source control where I can add different administrators, different roles into that system. And as you can see, there will be private endpoints as well. And then when I'm in that environment, of course, since I'm combining several areas, I also want to have a more in-depth look of what's happening in those systems. So even the pipeline runs and trigger runs and integration runtimes can be monitored in here, but also, for example, my Spark session. So you see which notebooks have been used, who submitted that, what is currently the status, is this really running, has somebody canceled it? So I see all my Spark sessions in here, as well as my SQL on demand. But this is only for, I don't have enough access rights in the end. See the history of my SQL on demand in here. So as I said, it's preview, it's work in progress, but we're adding more and more functionalities, like, for example, adding a Cosmos DB connector in here as well. So let's go back to that one. And hopefully, yep, it's loading and it has been executed. So it took a little bit longer. So run about 3 minutes and 2 seconds to get that session and run the first cell, and round about, 2 minutes to execute that one. So this is really a Spark on demand option. Other options, and I can have a more in-depth look what's happening in the Spark session as well. So going in here, going, for example, to see what's happening on the Spark side. So I have a really integrated feeling of those functionalities. And I said, let me switch back here. And I said, we are integrating things. And this is where I really want to hand over more or less to the visualization, which you will see in the next session. So going back home, going to visualize, you see I've got that. I can add more or less my own reports in here, but let me load that for a second. Close that. I've got the SQL scripts, I've got the notebooks, I've got my data flows, for example, but in this case, I also hooked up, I also have one Power BI workspace in here. So my visualization. So opening that, going not to the data sets, but to the reports, and I can query in the end my Power BI workspace and, for example, see and edit within that environment my Power BI work or my Power BI reports in here. I can create new ones, but in this case also using those functionalities, and you will see that in more details. So in the end, I've got my external data, I got this workspace or this environment to tweak, analyze that data, and I can in the end hand off to something like this, for example, because that's the dashboard which is more or less visualizing all those functionalities you saw in that workspace, and that can contain, for example, static pieces out of my data sets, maybe out of SQL on-demand queries. If I cache them in here would be an option, and I saw that the first customers who have very, very great solutions which they start to create using the SQL on-demand features, but also the live tiles which you see in here, which are currently from a streaming endpoint, also running through Azure Synapse Analytics. So that should be all for the demo so far. Do you have any questions? Perfect. So if not, thanks for listening, and I would like to hand over to Shimon.
Yes, Sasha, thank you very much. Great presentation. We like it. So we're gonna straight away to present the integration of Power BI on Azure. And this for sure based on the previous presentation in regards the data factory capabilities and of course Azure Synapse. So let me start the presentation and then let's head over to the last mile of our meetup for today. So most companies, they have the challenge that they have tons of data and different applications, different data sources, and they are not able really to bring all these data together. And the data factory and Azure Synapse clearly proved the ability to wrangle all this data in the right context and provide here good data models which can be used for proper visualization. And this is done by Power BI. So with all these powerful visualization and reporting capabilities be included. And with Azure Synapse, you have a petabyte of scale of analytics. So you can really bring tons of data, unifying those data and give the right context. And if it's necessary and you have the right persons in your organization, you can even create your own machine learning models on top of this data to enrich the data with advanced analytics and AI capabilities. So the data collaboration is crucial. We have different roles in each of the organizations. First of all, you have the business analyst, which is responsible to have an idea which kind of data I need to run my business properly. So then you have the IT professional, typically centered around the IT department. They have a lot of skills in regards creating data models, creating databases with the data and behind. Have a lot of applications running today, like ERP systems, CRM systems, and other systems as well. And then you have the data scientists, which have the deep knowledge what to do with the data, to classify data, to transform data and bring the data in the right context. And all these needs to be in a frictionless collaboration approach. And that's actually what we are doing with the whole Azure data stack and the data estate which Microsoft provides. And here we're going in the next step that we're unifying the organization. And the best approach, of course, would be using the Azure Data Catalog and Azure Synapse to have the right platform to bring the siloed data together in a common data model. And here we have the appropriate technology. That's the Azure Data Lake storage, which enables on top the technical answer of the Open Data Initiative to provide a unified data model around your different data sources. So Power BI, the Azure Data Services, and the common data model on Azure Data Lake is the answer of all these challenges with siloed data and bringing the data in the right context. So what is the typical workflow? You have the business analysts working together with the IT professionals to wrangling the data and bringing the data scientists on top of that to enrich the data. And how this can look like, I will show you a little bit later and specifically. So with Power BI, we have for business analysts a no-code, low-code ability to create really good data models and the visualization with, on top of that. So you're going straight away to the CDM folders of the Azure Data Lake and orchestrate all these things in the Azure Data Factory and ingest the appropriate data with the low or high code approach in your organization. And then you can model and serve with Azure Synapse, train and predict the data with Azure Machine Learning, or have advanced data preparation capabilities with Azure Databricks, and of course orchestrate all these different data streams in your organization to bring them in a unified data model. In this specific scenario, which I want to present you today, we have first of all many data which coming from different data sources. Like we have Dynamics 365 customer insights and data which was ingested in Azure Synapse Analytics, for instance, from SAP HANA. And here on Azure Synapse, we're unifying all these data in a common data model and bringing them in a standardized manner to have the connection to the data model of Dynamics 365 Customer Insights, which providing a different view on customers. So, and here we need to map and match and merge all these different data which coming from our customer. And if you, for instance, you are a retailer or you're running a customer-centric business, you need to bring these different data together. One hand, the customer data, what the customers are buying from you, what kind of buying behavior they have, what kind of preferences they do have, and all these we can really achieve with this unified common data model, which can serve here as a data platform. So, Customer Insights and Azure Synapse Analytics, bringing here for my use case for a retailer, two different options. First of all, customer data. Then other data coming from SAP, operational and big data, which was infused in Synapse Analytics. And the outcome should be really a 360-degree view of my customers and knowing specifically what they are doing and what kind of control mechanisms I do have to have make better decisions to for my business. So, and now let's go straight away into the demo. And this is a campaign analytics in retail with Power BI. And just to explain you what's behind in this demo scenario, we want to gain business insights from using historical and real-time data. So as well, predictive analytics for using structured and unstructured data sources coming from SAP as well, from Dynamics 365 Customer Insights. And we want to enable here the business analysts to connect to a line of business applications and unify their disparate customer data into a unified customer profile. So where we start? Let's start first of all in Dynamics 365 Customer Insights. I have here my dashboard to say how many customers I have in common. So what is the average churn rate, which means the customer, they go to another retailer in preferred and going there shopping. What kind of segmentations I do have. And this specific case, I made the segmentations regarding the different generations like Gen Y, Gen X, Gen Z, and Y, and how many customers I have in these different segments. Here in the data sources, you see here that I ingested as well different data sources into my customer insights. One coming from my Salesforce system, then from Dynamics 365 services, from my commerce portal, and from Adobe Analytics regarding the web usage from my web store. Here I tied with with an intelligent system called fuzzy matching different entities from these 4 different data streams, which I infused here in my customer insights. Like I have different measures, like a churn score, total number of customers, customer measures coming from customer insights. And then I have here, for instance, from the users, the contacts from Salesforce, the email activities, I am in contact with my customers. And from my Adobe Analytics system, I have all these website contacts and website clicks. Here I unify already my data model and mapping the entities because customer insights relies as well on the common data service. And what you can see here, I'm mapping from my Salesforce system the data model with a standard data model. Yeah. Like address, its location address, person, gender, and this is in fact the common data model which was implemented between SAP, Microsoft, and Salesforce and Adobe. And here I can unify these data models in a way. I can match them regarding the unique identifiers. Yeah, like here I see you have the Salesforce contacts, the Dynamics here, CRM service contacts, and so on, and can perform merge operations, as you can see here, to bring all these different data models together in a unified data model. Let's switch over to Synapse Analytics in Microsoft Azure. As my colleague Sasha showed you already, we have here data flows, which were ingested from different data sources as well from Dynamics 365. Like here are all the operational data coming from SAP HANA. And here I got, for instance, the last 5 years data and aggregating this data accordingly. Then I have a reference column, a derivative column, and then, of course, here's the outcome and can preview the data, what kind of data I have. These are primarily the sales data. Based on these data flows, and there you can see here, this is a 3-tiered approach. I can ingest these data, cleaning up with the ETL process, as many of you need to do that, cleaning up the data, formatting the data, and then bringing the data in an appropriate data model, and cleaning up the data, for instance, for non-usable data like blank data or with not valid data sets. Now I can start immediately using these data and creating Power BI. For instance, as you can see here, I have the whole data sets which are based on these data flows available. I can immediately start creating here a report which is created in Power BI. This is really, really cool. Let's let's see what can we do. So we have here the visualization options available with these default visualizations, which are included in Power BI. We have these typical ones like a column stack or and KPIs. We have 3 included AI-infused visuals in Power BI. These are, for instance, here the key influencer visual, as well the decision tree and the Q&A using natural language query processing. So let's start with that, for instance, to enable the line of business user creating on the fly report, bringing this report in an appropriate context. But let me switch over to a typical view of consumers in Power BI. So there are people, they created the data sets, and now I'm ready to use these kind of reports. For instance, this is a typical situation. I have here all this historical data, then I have the present one, the real-time location analytics, and then I have the future, for instance, to get a recommendation for my customers if they're buying, for instance, shoes, what they are buying as well. Yeah, like this one. Let's go over there. And here you can see a prediction of product recommendations, which are clearly based on the whole data which I wrangled together. For instance, customers who are used to buy running shoes. What kind of prediction I got, what they would buy as well. Of course, beach shoes, surfboards, steel corkscrew, surfboards, and so on. But here we say, and we have another insight regarding the buying behavior on a different timeline. For now, I see here there's a high demand on December before Christmas, and I can clearly see what kind of products my customers are buying. You can switch the view. For instance, if they're buying surfboards in California, for instance, they're buying shoes. So this is a real cool scenario which enables with Power BI a complete 360-degree view. Then I can have an analyze regarding the different retail channels. For instance, I want to see what's going on in my online stores. Clicking on that and see, the demand is equally high on December as well. Of course, because the buying behavior changed in the past, because the most people buying online today. Let's go back. Let me refresh this report and show you something really extraordinary as well. These are the AI capabilities in Power BI, which gives each of you, from an end user perspective, several capabilities to have advanced analytic capabilities in Power BI from an end user perspective. You see here the number of visitors by visits in the different departments. I have here a running flow regarding the real-time analytics from Twitter, what my customers are tweeting regarding my buying experiences and what kind of hashtags they are using. So I can go here inside the report, because we are now on a dashboard level, which is an accumulated view on that. So I want to know what kind of tweets are fired from which regions of the world regarding fashion. And let me just make the map a little bit larger and can then filter on different regions. For instance, here in Middle East, I want to know what are the people thinking about the buying behavior. Yeah. So, and then have all the required tweets and insights from my customers included. This is really cool. And I know directly, this is here from Holon, that's a customer located in Israel. Good, fantastic. Then let's go to another analytical view in regards Power BI to showcase. Give me 1 second. How performant Power BI actually is. So let me, for instance, showcase here. I want to know how many data sets I have here in and I'm performing a count on the product ID. Category ID, sorry, and getting an overview regarding the whole performance. Now on the fly, I want to analyze the amount of customers which I do have in account, and I have in my database 30 billion customers. And you see, this is quite impressive how fast Power BI behaves if I want to perform a multi-billion count approach on my data set. This is quite massive. Here I want to have analyze by category and the product ID, and with the product ID I want to have the profit. So to have a very easy going bar chart, analyze, and here we are. Takes a while, but it's immediately there. Let's have a more sophisticated view regarding a campaign and what kind of profit I realized with the campaign. So I have the profit and can go now here by campaign and see directly that the campaign Be Unique raised the most profit, is the most profitable. Then the tailored for you the second, and so on. And these are typically things you need to wrangle with a lot of queries, and Power BI delivers this capabilities on the fly with these AI-infused capabilities we see here. This is really cool. I can now save this report and make it a little bit visual better, and perform an actualization of the data if it's required. Can choose the different the different log aspects. I can, for instance, now log this report that nobody else can edit the report, and so on. This is really cool what you can do with the direct integration of Power BI into Azure Synapse. And to make it short and doing the summary, so with Power BI and the Azure Data Service, you have really a great chance to breaking up the silos of data in your organization. You have one data lake for all the data. You can unify the data with the common data model and the common data service. You have an unlimited scale to use cloud-based resources with Azure Synapse as a modern data warehouse solution of Microsoft. And you can enrich the data with AI-infused visuals, as well with AI-infused machine learning models, which are pre-trained And we call these at Microsoft auto machine learning, really to enrich all these different data types which you are ingesting in your data. And then the consumption is quite easy, as you have seen. Power BI is directly embedded into Azure Synapse, and you can start to create on top of your data models the Power BI reports. That's it from my side. Short and crisp at the end. I want to say thank you very much for for the attendance. Have a nice evening, and hope to see you soon at the next meetup.
Well, thank you, Simon. So just before everyone leaves, just let me quickly bring up the slides that we had at the beginning. Is it it's loading? No, it's not loading. Just give me 1 sec. Okay, we do it like this. So now, before everyone leaves, I just want to give a quick reminder that we will upload the content from today to this GitHub repository. So just feel free to look in, maybe not today, but maybe in the next couple of days. These will be filled with the slides and the other material that we have shown today. And as Daniel was mentioning in the beginning, we will have our next meetup at July 16. And this one will be centered about data and AI in healthcare. So we will show great stuff like BI as a service. We have great customer talks and partners who present on many, many more data and AI topics. So stay tuned. And as we also mentioned at the beginning, if you have some ideas about speaking at one of our data and AI meetups, then just please feel free to submit your session proposal at this link. And well, this brings me then to the end, or let's say to the very beginning of this slide set. And we have some time for questions. So if you have something to ask, please feel free to unmute yourself and ask. If not, you can also reach out to us afterwards, of course. Join the LinkedIn group or join our Twitter feed, Data AI Hub. If there are no questions, and well, I guess after these plenty of well, after this many information that we got today, I guess it's okay to close the meetup for today, and then we wish you all a very, very good remaining day, and see you in the upcoming meetup. So, bye-bye.
Bye-bye.
Thanks, Alexander. Yeah, bye-bye.
Goodbye.
Bye-bye.
Bye-bye.
So this was Noah saying goodbye. Also goodbye from him, and goodbye, everyone.